Last video of the night, finally. This is section 9.95. We're looking at the effects of changing dimensions. We have a bunch of numbers that kind of go around all here, but I'm going to say try not to look too much at the numbers. Instead, focus on formulas. Seems like we tend to see the change a little bit better when we're actually looking at the formulas. So instead of looking through this one, let's just go ahead and get started. So we have the first one here. The base and height of a triangle with vertices blah, 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 blah are tripled. I said blah, blah, blah because I don't really care about those. I care about the idea that it's tripled and that it's a triangle. And that I'm saying the base and the height are tripled. And it's asking me about the change on the perimeter and the area. Well, perimeter is going to have the same change as lengths. Oops, I can't even spell there. So if the perimeter if the lengths are tripled, then the perimeter is also tripled. But let's look at the area, because that's one that's kind of interesting. If I know that the area of a triangle equals half the base times the height, but now I have a new base and height because it's being tripled. So the base really changes to 3 times the base, and the height really changes to 3 times the height. I'm going to replace those into here and see what happens. So then the area is equal to 1/2 3 times the base and 3 times the height. Well, if I kind of move things around here just to get it back to where it started, the area then is really half base height times 9. Well, that's my original area. So it has my original area, this half times the base times height, times 9. So the area doesn't get tripled. The area is multiplied by 9. So that's an interesting relationship there. It's multiplied by 9. It's not tripled. It's not times 3. It's times 9. Let's look at another one. Similar idea. The side length of a square. Again, I'm not really looking at the vertices. I'm just looking that it's a square and it's doubled. Well, if I have a square, here's my square, and then each side length is going to be doubled. Well, that means that originally this was like a base and this was a height, and really this equals the base and this also equals the height. So if I were to try to find the area of a square, it's just b squared or h squared. It's one of the sides squared. Well, it's saying that one of those sides is doubled. Well, if the area equals b squared, but b is really going to become 2 times b because it's doubled, then that means that the area is equal to whatever that new base is. We're going to plug that in, 2b squared. Now if I plug this in, that means I get 4b squared is my new area. Well, that's just having my original area, but now times 4. So my area, the change in area, is that it's multiplied by 4. Let's see what happened to the perimeter. The perimeter should maintain the same change, but just to check it, now that we have a square, we have a little bit easier version to check. So here's our square, and each side starts out as b, 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 and b. But now we're going to change those sides. So our original perimeter is just 4b. But now in the new one, let's draw another square here. This is not b anymore. It's going to be, so it's 2b, 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 and 2b. If I add up all those together, that equals 8b, which is really 4b, my original one, times 2. So it also was doubled. So the perimeter is also multiplied by 2. Okay. So perimeter seems to maintain the same kind of thing, and the area seems to get a little bit bigger. Well, let's see what happens with a circle. Let's see if it's consistent. So we start with the circle, and we don't really care what the numbers are originally, what the original radius is, but we do care what the and perimeter was, and then how that changes in relationship to the formula. So the area to start with is just pi times r squared, but the radius is changing. It's multiplied by a half. R is now becoming 1/2 r. So I got to replace this radius with this new one. That means the area is equal to pi times the new one, which is 1/2 r squared. Well, this squared is going to square both the r and the 1/2. So that's just pi times r squared times, what's 1/2 squared? It's 1/4. So again, I have my original area times 1/4. So it's not times a half. The area is multiplied by a fourth. Let's look at the circumference. Circumference starts out as 2 pi r, but again, r is going to be changing. It's going to go to 1/2 r. So now my new circumference is going to be 2 pi times 1/2 r. Well, if I regroup that again, I still get 2 pi r, but this time times a 1/2. So how does that affect the circumference? Well, it's just the circumference is multiplied by 1/2. That's the change there. Why am I going through this trouble to check it? Because it's not always consistent, and we got to be careful. Sometimes if we only change one dimension, it doesn't change in the same way as if we change both. And in a circle, there's really only one dimension that matters, just the radius. So we got to check it and see what does happen. Let's finish with this last one here. The base and height of a triangle is multiplied by 4. Well, we know that the perimeter maintains the same, so the perimeter is just going to be multiplied by 4. Perimeter is multiplied by 4. What then I want to look at after that is, what about the area? Well, area starts out as 1/2 base times height, but now the base is becoming 4 times the base because it's multiplied by 4. But so is the height too, and the height is multiplied by 4. So h is also becoming 4 times the height. That means that my new area is going to be 1/2 4 times the base, because that's my new base, and 4 times my height. Now if we're to kind of move this around, I could regroup it as 1/2 base times height times, and then we have 16. So how does the area change? The area is multiplied by 16. Cool. Very cool, very cool. There's more examples like this, and one thing that you want to be noticing is that what if only the base was changed, or what if only the height was changed? That's when something different kind of happens. When you only change one dimension, you only change it by a factor of 1 where it has the same change. It's when you change more than one dimension, base and height, that you get this. Or if you go back and look at the circles and you change something that winds up having a double impact, r squared, that's when it gets squared in the change here. Alright, that's all. Have a good night.